Hi, I'm Nidhi Pandya, and this is my Lab 1 Charge on Tape presentation. The purpose of this lab was to learn about charges and their interactions using everyday objects. This lab provides a model of point charge interactions and the forces involved, as well as providing a computation of the electric field of a point charge at different locations. The result of this lab was that the system of two tapes was found to be in equilibrium, and the forces of gravity and electricity were found to be equal and opposite to each other. Overall, the tape was positively charged and attractive to negative and neutral objects. The charge on the tape was determined to be 9.33 e to the negative ninth coulombs. The experiment involved two interacting U-tapes. So the expectation was that the repulsive forces would push them apart because they have the same charge. And in the experiment, it was found to be true. And then the second question was, is a U-tape positively or negatively charged? And the expectation was that if it was positive, it would share attractive forces with the negatively charged plastic pen. If negative, it would share repulsive forces with that pen. And if neutral, it would not have attractive or repulsive forces. And through the experiment, we found that it was positively charged and therefore shared attractive forces with the negatively charged plastic pen. So for the main experiment, two pieces of clear tape were ripped apart to create charged tapes. One tape was hovered in the air using the electric force of the other tape, opposing the gravitational force of the Earth on the top tape. Because the top tape was in equilibrium, the electric force could be computed by first calculating the gravitational force, and then the electric field and charge could be computed algebraically. Some of the observations recorded during the experiment were that the two charged tapes repelled each other. The charged tape was also attracted to neutral objects in a more weak attraction. If electrons had positive charges and protons had negative charges, then the tapes would have opposite charges than documented. And it was really important to handle the tapes carefully because the charge will be absorbed by the neutral objects in contact. And then overall, the tape was positively charged, attracted to the negatively charged pen. The physical principles involved in this experiment were Newton's third laws, when the two tapes exerted equal and opposite forces on each other, and that's what caused the hovering, and Newton's second law, when we assumed that only two forces acted on the top tape, and using F equals ma determined the gravitational force, and that was used to determine the electric force on the object. The charge was computed by measuring the electric force and then using the principle F equals electric field times charge. So the actual data recorded per the handout was to first find the charge of the U-tape. The length of the tape was 0.2 meters, the mass was 0.00 kilograms, the distance between the tapes was 0.02 meters, and then the gravitational force was found using F equals ma as 1.962 e to the negative 3 newtons. The charge on tape was then found with that formula, and it's found as 9.33809 e to the negative ninth coulombs. And then after that, we could find the corresponding number of electrons by dividing the charge of tape B over the charge of one electron. And that was found as 5.84 e to the 10 electrons. And then after that, we found the fraction of atoms that gave up the electrons. And that was found as 29 electrons per atom. So the last part of the lab asked to create a computational model of the situation. So I created a point charge model of the two pieces of tape, tape A the top tape and tape B the bottom tape, shown as the two blue spheres. Computed the force of gravity on tape A using the gravity constant on Earth and the mass of the piece of tape, and then solve for the charge of one piece of tape, solve for the relative possession vector, the magnitude of that, and then the unit vector of r, and then use those values to compute the electric field, and then use the principal force equals electric field times charge of the top tape to compute the electric force on the top tape due to the bottom tape, and then model the forces acting on the top charge as the green arrows, And then finally compare the electric force to the gravitational force to check if the charge that I calculated makes sense. So in conclusion, I learned how charged particles interact using everyday objects and understood Newton's laws in context, and then also used GlowScript to model a real-world situation.